Let me introduce myself a little bit. My name is Bruce Nguyen. I'm a senior solution engineer here at JFrog. I came to JFrog with about 20 years of experience, having worked in many different sectors, from healthcare to insurance to utilities. In addition, I have also worked in various domains, from developments to release management to operations. So I came from a diverse background, and so I understand a lot of the pain points and that many of the development community face today. I'm very excited to join JFrog in that we are at the center of the DevOps revolution. With that, let me start. Here is the agenda for the webinar today. We will go into what is an artifact repositories. I'll explain some of the rationale why we need it. And then I will also explain some of the use cases, particularly for Artifactory with respect to resolving dependencies. It's also as a use case for deploying targets. At the end of the day, Artifactory is a system of records for your build and build management systems. First off, what is an artifact or a binary artifacts in the DevOps space? First off, from a development perspective, we start out with your source code. In order to build anything, you typically depends on various libraries, third-party libraries, various what we call dependencies. That is true depending, regardless of the technology that you use, whether you're using writing Node.js, there's a lot of dependency, or if you're writing Java or even C++, there are always dependencies, whether you are depending on other groups within your organizations or open source third-party libraries that you might depend on. And then using the compiler, in this case, if it's a Java, we would use the Java compiler to build the binaries in combination with the dependencies, and the output of that would be packaged into a binary artifacts. So in the case of a Java world, we typically see a jar or a Word file as a binary artifacts in that case. Artifactory is a universal artifact repository. What it meant is about universal is that within a single platform, you can manage a lot of different technology together, from NuGets to Gradles to Vagrants to NPM, Debian, Docker packages, Python, and so forth. We also support many integrations. And so if you are using like Jenkins or Bamboo or TFS, TeamCity as your CI server, all those works in conjunctions on top of Artifactory. And so that's why we call Artifactory as a universal artifact repository manager. But from an artifact perspective, you can say that, hey, why can't you just use your source control systems? Because you already make that investment in your current source control system. So why can't I just use the source control systems? Well, let's take a look at some of the differences between source versus binary. First off, source is text, whereas a binary repository manager manages blobs or binary objects. With source, you can diff them. In binaries, you cannot diff them. Source is often versions by content, whereas in the binary, it's version by name. Source is mutable, whereas binary, it's immutable. So once the objects are created, it doesn't modify. Here is a more pictorial view of example where we have the source using with text. You have different versions, and you edit the content of that text file. Whereas in binaries, you typically create different versions of the binaries. As you can see, some of the problem that might become quickly apparent as you create many versions and as you do continuous building and integrations. There could be a lot of versions created as part of the process. So you might have heard Git of S. If you already got Git of S, so why can't we just use store your binary object to build in the Git of S? Here is one of the co-founder at SourceTree, Steve Strading. His personal experience with being the early developers and adopters of Git is that as you store binaries inside Git, it clogs up the whole Git repository, slows down everything, put everything into a screeching halt. In addition, you can't even clone the Git repository as your teams gets large and distributed. Cloning is become impossible because there's no way to really clone a subset of a Git repository. Okay, but then let's play devil's advocate. Why can't I just use regular file system to store your binaries? That's what has been working for some organizations in the past. So what's wrong with just using the file systems for binary storage? Okay, let's explore that thought for a minute. First, let's come up with a set of requirements for managing those set of binaries. First, you do have to manage the third-party libraries that are coming from various sources, such as JSON or Maven Centrals, where you have to proxy those other repositories in order to pull down those dependency artifacts. Second, it'd be nice if we can search it by name, context, and possibly content of the artifacts. And then third, perhaps you might have to manage the artifact lifecycle. With everything that you build within your CI/CD pipeline, you want to make sure that it goes through proper testings, security validations, and approval before you can deploy to productions. And so the life cycle applies to the artifacts that are being produced as part of your CI/CD pipeline. And then, as you can see, with the many versions of binaries, you quickly run out of storage in that file systems, and so you got to come up with some kind of mechanism to clean up your snapshot builds. And then as you're running out of storage and the storage gets costly, you might have a need to optimize your storage size so that it becomes more manageable. And by the way, you might want to enforce module security. For example, certain modules, for example, your license manager component, you might only want to allow a very subset or very small groups to have access to those components. And so module security, it might be applicable. And then, by the way, it'd be nice to expose the REST API on top of this set of artifact repository in order to access and to manage the all the above set of requirements. And your list of requirements can certainly go on. Well, if you actually go through all that and build it yourself, well, congratulations, you have just wrote a binary repository manager yourself. By the way, for Artifactory has been in development for the past 10 years. We currently have about 200 developers working on them. And if you follow some of the Artifactory updates, you can see that every few weeks there will be a new release with significant enhancements to Artifactory coming out constantly. And so it is a huge endeavor in order to build Artifactory as a repository manager. Just want to specifically on one of the key features of Artifactory is that it optimizes storage. Artifactory manages binaries using a checksum-based storage, where if you have multiple artifacts stored in Artifactory, it uses a checksum, it calculates the checksums, and it stores the artifact once. And so as you create multiple copies from dev to QA to productions, you effectively only have a single copies, and so you quickly gain the benefits of storage optimizations with Artifactory. So a little bit more detail. So what is a JFrog Artifactory? With that, let me do a live demo for you. Here is JFrog Artifactory. This is a sample artifact instance where we had set up with just relatively a few builds and few artifacts. It's a relatively clean slate for Artifactory. But with Artifactory, as you could see earlier, as a universal repository manager, we store a lot of different type of repository from Docker to Gem, Gem for gems to Git LFS, which means cache Git LFS, Ivy, if you're using Ant-based builds, Mavens, various libs, and so forth. Artifactory maintains all these different types of repositories on top of the single instance of Artifactory. In this particular example that I've set up here is that what I have set up is a Jenkins job or Jenkins pipeline where we have 3 jobs. One is to create the WAR file. The second is to create a base Docker image. And the third is to create the Docker image. And when you go to Artifactory, you can see that Artifactory manages the builds and all the artifacts that it manages. In this particular case, you can see that it creates 4 different set of artifact components here. In particular, the services jar and the shared jars are created with our dependencies. The API, on the other hand, has a bunch of other third-party dependencies that we pull from JCenter. In addition, it also pulls in the shared jar that was just created in the other module. And then we also have the web services, which is a WAR file that brings in many other third-party jars. In addition, it also pulls in the shared jar, and it also pulls in the API jar that was just created. With the second steps for Artifactory for Docker, Artifactory can also handle Docker images as well. In this case, it creates, it pulls in a couple of dependencies, namely it pulls in the Apache Tomcat dependencies and the Java JDK 8 libraries. In addition, it pulls together the framework for Docker, and in addition, it pulls in a few other dependencies. In this particular case, you can see that it pulls in Ubuntu as the baseline for the Docker images here. And in the third build, it also is similar. It pulls in the WAR file that we created in the prior Jenkins job. The latest version 2.2. And in addition, it for the Docker image itself, it pulls in other baseline images in addition to deploying its own set of or its own stack of Docker images as well. That is Artifactory managing all the types of images there. Going back to the present. Okay. Oh, sorry. Let me go back to the slides. Okay. So let's take a look at binary Artifactory binary repository managers in conjunctions with your CI/CD pipeline, because just having the binary repository managers, in order to do a DevOps, you certainly have to automate your CI/CD pipeline. Artifactory in general is more than just a place to store your image. It is a system of records for managing other metadata on top of the Artifactory itself. One interesting experience we notice is that as we combine binaries with build info, it creates that awesome combinations that that make DevOps complete. If you could imagine the metadata on top of Artifactory, it effectively becomes the bill of material for how those artifacts were constructed. And so it becomes the standard truth for documenting all the informations that could be captured as part of the build informations. And so it gives you traceabilities on how the artifact was developed. From from a life cycle perspective, as you could imagine, having a developer, first the developer, depending on the technology the developer works on, if, say, for example, he might be on a .NET based framework, he might be working with the NuGet client to define the set of dependencies or libraries of other DLLs that he might be depending on. If he's a Java-based developer, he might be defining dependencies using Mavens or Ivy or using Grados to do the build. The first thing he does is to validate his code against the third-party libraries. And so in order to resolve those libraries, first it goes to Artifactory to resolve the libraries. Artifactory for the first time would not have a copy, or would likely not have a copy of that libraries. And so Artifactory turns around and goes to a remote central repository like JCenter or Maven central repository to pull down that artifact and store a cache copy of that artifact. And then Artifactory would again return the artifacts back to the build environments, and the compilation was able to proceed successfully. Now the developer would commit his code along with the build dependencies into version control. A second developer can go through the same process and does the build. Again, Artifactory would just deliver the same image that the first developer download. And so you have consistency from developer to developer instead of having n number of developers going searching the internet and downloading the appropriate jars. So by utilizing Artifactory, the first thing you notice is that it provides the consistency between developers. The first thing that happens once the build checks in, if you have a continuous integration set up, usually there would be a webhook that triggers the build upon check-in. So it depends on your tool of choice for your CI servers. In the example I showed earlier, it was using Jenkins as the CI server, but using any of the available CI server, be it TFS if you're on more of a Windows-centric environment, or TeamCity or Bamboo Jenkins could be used for any other. The first thing that happens with the CI server is that it takes a look at the check-in and the build dependencies that was defined by the developer, and the build would run, and it needs the dependencies in order to do its compilations. And so the dependencies, again, would go back to Artifactory to resolve the dependency. And then Artifactory deliver the same image or the same artifact that was downloaded earlier by the developer, and make it available for the build. And so, as you can imagine, the CI server now has the exact same copy that was used by the developer in his development effort. And then as the build completes, the build will push the artifacts that was produced in addition to the build info or the build material along with the artifacts into Artifactory. Additionally, as the QA team gets to take a look at the code, so if the code gets automatically deployed to a QA environment, for example, the QA team can, in addition, contribute to the metadata. The QA team might be using tools like JMeters in order to validate and qualify certain build. The information could be by using tools like JMeters. The tools can update the artifacts by adding additional properties or metadata attributes on top of the artifacts that was created. And so you have further additional traceability and quality validation as part of your CI/CD lifecycle. And as the code completely gone through the QA life cycles, go into deployment in a production environment, you might be using any of your popular deployment automation tools such as Puppet, Chef, SaltStack, and so forth. Those same tools would turn around and call and retrieve those artifacts from Artifactory along with all the final build, and in addition, you can see that the entire quality process has been validated before the actual the final product gets deployed into the production environment. In addition, if you have a need to distribute your artifacts to the general public, bin tray is also another viable target to finally release your product. Say, for example, if you are building in-house and you have a need to release to the general public, bin tray is a great platform for public distribution of your binaries. With that, let me go back to the demo and show you a little bit more about the build material that I was presenting earlier. Can you see my screen? Okay.
So
awesome.
when you scroll, just scroll a little slower.
Okay. So earlier we saw the build the build one created the build information. In this case, you can see that the build agent was a Jenkins pipeline using the Jenkins user ID to publish the artifacts, and the dependencies is what you saw earlier. In addition, you can also see the environment variable that was created at the time, or it was captured at the time that the build was actually executed, along with the system variables for producing that particular build. You can also see that with integration with X-Ray, we can detect the license associated with the components that you're depending on. So in this particular case, the Commons Upload library was an Apache 2.0 base license that you can depend on. And so with the X-Ray integrations, you can actually have the ability to stop the build if your organization does not approve a certain type of open source license, for example. Using the build materials as you run in production or in QA various environments, and as you run into issues, you can quickly compare the builds. Say, for example, between your development and QA, you can see the differences between what was changed between the two builds that got deployed. And as you can see in this case, certainly the product that got deployed was changed, namely because the artifact version, the build number was changing in those cases. You can also see the dependencies that was changed. In this case, for this particular build, it changes dependencies for the two shared libraries because the number, the build number was incremented in that case. But the other variables, you can rest assured that it did not change, and those third-party libraries that you depend on did not change, and so it eliminates those set of concerns that might arise out of say errors in this Java assist component, for example. In addition, you can also see the environment variables, what changed between the two builds. In this case, since the build number did change between the two builds, these environment variables did change, but many other variables did not change from your Oracle 8 Derby home environment, which relies on the Oracle 8 path, to your JRE, for example. Those did not change, and you can rest assured your Java version remains intact, and so you can rest assured that those were not moving parts between your build environment. Release history, since this is an intermediary pipeline, there was no actual release, but you can see the entire build info. If you go to the third pipeline, where similarly you can see the general info, the environment, the environments, the diff. You can also compare, say for example, between two Docker build images. You can see that layers by layers, it was able to detect that these layers did change, but the majority of the other layers within the artifact within your Docker image did not change. One thing to note specifically on Docker is that Artifactory manages each and every layers of the Docker image as a separate artifact, and so it has the ability to compress your image, your Docker image significantly. The Docker image often is one of the larger image, but then once it's checked into Artifactory, once it's deployed to Artifactory, only these layers would be stored, whereas all the other lower layer prior layers here did not change, and so it did not need to maintain another copy, but it simply provided additional references. Similarly, all these dependency layers that was brought in did not change as part of the build. On this particular build, this did include the layers WAR file that was generated from the step one earlier. That did change, and so Artifactory detected those changes as well. And similarly, you can compare the environment variables. The release history, as far as the your promotion process, you can have as deep of a promotion process as you like. But in our sample here, we take it from build to a production repo, and when we do a production promotion, it basically propagate the build image or the Docker image into a production repo, and by that it did track the status of the promotion as a release status. You can have more fine-grained promotion process as on an as-needed basis. And of course, you can also see the entire build info. So that's at the high level of this is why Artifactory, in combination of the bill of material, I just want to go back and show you the Docker image itself. Within the Docker images, you can see that Artifactory maintains all the layers inside Artifactory, and efficiently captures and store layers by layers, especially for Docker images. And this is the property earlier. You can see properties, but this is where QA team can add additional properties on top of the artifacts that you maintain within Artifactory. With that, I will now open up for questions that you may have.
Awesome. Thanks, Bruce. Okay, so we have some good questions. First question is, for checksum-based storage, which checksum do we use?
So we use SHA-256 checksum. actually we use SHA-1 to actually create the name, and then that's what we currently use as the checksum for the object storage.
Awesome. Does Artifactory have REST API to get a list of dependencies used for a specific build?
Yes, you can certainly get the entire build info along with which includes all the dependencies from the REST API. Artifactory is all about the API. The 90% or 95% of actual Artifactory usage is via the REST API. Most of the time, for example, when you use the NuGet, for example, if you're using the Maven or NuGet or any of the client, you just or even Docker, you can stay within your local client, and Artifactory actually serves all the all the artifacts, publishing the build info and so forth via its REST API. So Artifactory REST API is the heavily used, and it is the most every REST API is well documented on our website, and so you can get additional details there.
Awesome. When Artifactory downloads a dependency from central repo, say Maven, does it cache anywhere, or is it stored in the Artifactory repo it's created?
So Artifactory has what is called three types of repository. One is the local, second is the remote, and the third is the virtual. The remote repository is used to cache other repository from other sources. It can also be caching from other Artifactory instances as well. But once an artifact is referenced via the remote repository, it will download it. It will keep it in its remote repo. It actually calls a remote repo that's cache, and you have the options to certainly clear those cache at some point if they're irrelevant. But that's how Artifactory manages its copy in a repo itself. Keep in mind, Artifactory does store everything, including the local artifacts, inside the same object storage, and so it has the ability to cleanly segregate all the artifacts under the one umbrella.
Okay, so I guess follow-up question: if you want to restrict Artifactory from downloading a particular version of a dependency, can you set up a rule?
Yes, you can certainly set up a rule with, especially with X-ray integrations. You can have the ability to stop a download, or you can actually do that within Artifactory itself to block further download for that particular version of the artifact.
Awesome. Okay, we're going to take two more questions. What is the persistence layer?
So Artifactory typically manages files or its artifacts in either in the file systems or in an NFS share or in object storage, such as like an Amazon S3 bucket, or you can just simply store that on the flat file systems. For the metadata, on the other hand, Artifactory stores that in any of the popular relational database of your choice. By default, if you just download and install it, it comes with Adobe database. But Adobe can serve for an initial trial period. But as you scale up to hundreds of gigabytes or more, you certainly want to migrate to a more production database.
Awesome. And then, can you cover the version differences between Artifactory and maybe introduce X-ray a little bit?
As far as I'm not sure if I fully understand what is meant by the version differences. But earlier, when we were talking about the various versions of Artifactory, Artifactory manage its versions by name instead of it's not just Artifactory, but it's binary in general. It's version by name, and so it becomes technology dependent on on coming up with certain conventions. For example, with Docker, you typically use a tag to version on a Docker image, whereas product versions.
A follow-up question.
Okay, I was going into the versions, but with the product versions, Artifactory comes with OSS, which only supports Maven-based repository. But the Pro Editions covers is what I was showing earlier, which is a universal repository manager. It supports all the different type of packages that are out there. And then our Enterprise Editions mainly focusing on providing the features that enterprise often needs, such as high availability, multi push pull mechanisms and so forth. And so those are more focused on enterprise scale features for the Enterprise Edition.
Awesome. Okay, well, that's all the time we have right now for questions. Thank you again, Bruce, for your time. We're going to follow up with an email to everyone with the YouTube link so you can watch this this webinar again, and we'll answer any outstanding questions we have over Q&A. All right, thank you, everyone. Thank you, Bruce.
Thank you.
Bye.